You know that smell, that really specific, unpleasant one you sometimes get near big industrial areas? Well, a lot of the time, that's actually coming from our essential water and sewerage facilities. So today, we're going to unpack a brand new blueprint that's designed to clear the air by tackling this invisible problem right at the source. Look, sewerage facilities are absolutely critical for our health, but they come with a stinky side effect. Processes like this, an open inlet channel, they release smelly gases that can really impact nearby communities and the environment. I mean, we're talking about real quality of life issues here. So the big question has always been, how do you manage these smells in a consistent, scientific way? You can't just cover things up and hope for the best. It needs a real engineering solution. And that brings us to this comprehensive new blueprint, one designed to clear the air for good. All right, here's how we're going to break it down. First, we'll look at the new official standard that's changing the whole game. Then, we'll dive into its core philosophy, which is all about defining the problem first. After that, we'll see how it works in the real world by containing the source. And finally, we'll get into the hard numbers that tell us if it's actually working.
Okay, first up, the new rulebook. Let's dig into how the industry guidelines have evolved to finally get a handle on this issue.
For a long time, the go-to guide for engineers and designers in Malaysia was this, the Malaysian Sewerage Industry Guidelines, or MSIG for short. These were the documents that covered, well, pretty much everything.
But then, a really big shift happened. In recent updates to these guidelines, a new instruction appeared. See that highlighted line for odor control? It basically says, hey, don't look here anymore, you need to refer to this other document. And this is it, the SPAN TS 3009-2022. This technical spec is now the one and only rulebook. It's the definitive authority for designing, building, and even testing any odor control system in the water industry. A single, focused standard for everyone.
So what makes this new standard so much better? Honestly, it all comes down to one really powerful idea. First, you have to define the problem. This is straight from the standard itself, and it is the golden rule. It says you have to perfectly and accurately define the entire problem before you even start thinking about a solution. It forces you to be methodical, to be scientific, instead of just guessing. And this whole philosophy gets broken down into three really clear, logical steps. Step 1, figure out exactly where the smell is coming from. Step 2, design a system to trap that smell with covers and then pull it away. And step 3, you have to scientifically measure just how strong that smell is. All right, let's see how this blueprint actually works in the real world, starting with that super important first step, containing the source. The standard leaves absolutely no room for error here. It makes you do a full analysis of the entire facility, identifying every potential hotspot, from the second the wastewater comes in, through all the screening and cleaning processes, all the way to the final sludge treatment. So, once you've found a source, you contain it. But, and this is key, it's way more than just slapping a lid on something. The standard is very clear. Containment is a two-part process. First, you isolate the gas, and second, you actively pull it away. And this picture just says it all, right? On the left, you've got a typical open tank, just letting smells drift out into the air. On the right, that same tank is completely sealed with a custom cover. The difference is just dramatic. And it's the exact same idea here with this screening equipment. The old open design on the left is a major odor source, but the modern, fully enclosed unit on the right, it completely isolates the whole process, trapping all that smelly air inside. Okay, so you've covered it. Problem solved, right? Well, not so fast. A cover only traps the problem, it doesn't get rid of it. If you just stop there, you could get a dangerous buildup of nasty gases under that lid. You have to actively get that trapped air out of there. And that's where the local exhaust system comes in. The best way to think about it is like a giant, powerful range hood for your kitchen. Its job is to create a slight negative pressure, like a gentle vacuum. That way, clean air gets pulled in through any tiny gaps, and the smelly air can't get out. It also safely whisks away all those trapped gases. So, we've found the source, we've contained it, and we're exhausting the foul air. Great. But how do we actually know it worked? This brings us to the finish line. How you measure success. This, for me, is where the new standard is a total game changer. It gets rid of subjective things like, I think it smells better. Instead, it sets hard, non-negotiable numbers. Every single system has to hit these targets to pass. Period.
Performance target number 1 is all about removal efficiency. Whatever technology is being used to clean the air, it has to remove a bare minimum of 90% of the odor.
And target number 2 is an absolute limit on the final product. The treated air that gets released back into the environment cannot be stronger than 1,000 odor units per cubic meter. And an odor unit, just so you know, is basically the faintest level of a smell that an average person can detect. So this sets a very clear limit. And you absolutely need both of these requirements. The 90% rule makes sure the technology itself is working like it's supposed to, but that 1,000 unit limit guarantees a good result at the end, even if the air going in was unbelievably stinky. It's a real belt and suspenders approach, and it ensures clean air every time. When you boil it all down, the real power of this new standard is that simple but strict problem-first approach. By forcing a clear, scientific definition of the problem before designing the solution, it creates a template for success you can use again and again, and it really makes you wonder, right? What other huge, invisible challenges are out there just waiting for the right standard to come along and solve them for good?